Okay, so this is the same file. I'm going to comment out the flowers for right now so they don't distract us. And we are going to create a rotating line. Hopefully I can do a rotating polygon also. We'll see about that. We'll start off with a rotating line. And a rotating line needs to know the x and the y and the length of the line. X and y in this case is the center of the line because it's going to rotate around the center. Okay? So we come down here, and again I'm going to do a class. I hope that's not too confusing, but the purpose of a class is to combine data and actions together. And so it's convenient because it provides a container for what I'm working on. So we're going to call this rotating line, and we need our init, which is what sets up the line, x, y, and length. And you may have noticed this extra parameter self, that represents the object itself. Okay, so it's the thing that has the data inside of it. So self.x equals x, self.y, and these could have different names. I just tend to do this where I name the parameter here the same as the instance variable here. Self.length equals length. Okay, now we need a self.angle equals 0, so it'll start off horizontal. And then we say self.line equals canvas dot create line. So we need x, well, I can use x minus length over 2 y, x plus length over 2 y. Width is what it's called, right? Width equals 2. And so let's see. Okay, x, y length. Oops. I need to fill in values for those. So 300, 100, 100. Okay, now let's try running this. Bink, and there's my little line. Of course, it's not rotating yet because I haven't done anything. And so now we need to do our root dot after, and so this means that after so much time, 100 milliseconds, we're going to call rotating line dot rotate, and we need to pass it the object. That's what the self is. And so the self contains the x, y, length, angle, and the actual line from the canvas. So, and I didn't mean to hit an extra reach. Okay, here we go. Def, and this is rotate, and it gets self is the only parameter that it gets. And so we're going to do radians equals, first let's increment angle. So angle plus equals, we'll give it 4 degrees for right now. Yeah, we'll give it 10 degrees. We can adjust that later on. Then we're going to say, oh, this is self.angle. I have to remember that. Radians is just a local variable. Equals degrees to radians, self.angle. So x0 equals self.x. I'm sorry, so x0 is one end of the line. So we're going to have x0 and y0 on one end of the line, and x1, y1 on the other end of the line. And so x0 is going to be self.x plus math dot sine of radians times self.length over 2. Y naught equals self.y plus, yeah, this seems backwards. Doing sines for x and cosines for y seems backwards. Well, we'll see what happens. And I put a semicolon there because I'm still thinking in C. And this should have been minus. And this should be minus. Okay. Because now x1, y1 is going to be, I hit the wrong key. This is going to be plus. So obviously I could have saved math.sine and math.cosine in variables so that I didn't have to recalculate them. We'll give this a chance and see what happens. So now we say canvas dot chords self dot line x0, y0, x1, y1. And so that should rotate the line 10 degrees. So it starts off flat. It should be slanting uphill just a little bit, if I did that right. Let's see what happens. Well, it's close, except it rotated at 100 degrees instead of 10. So, yeah, I had it backwards in my mind. This should indeed be cosine, and this should indeed be sine. I said it seemed backwards, right? Cosine is typically associated with x, sine is associated with y. Whoa, why is it going backwards? So that is this sign here. Still going backwards. Oh, because y is reversed. So I shouldn't reverse both of them. I should just reverse y. There we go. And so now I can say root dot after, and we'll try 100 milliseconds. Rotating line dot rotate self. And there it goes. It's rotating around its center position. Sorry. Which was kind of what we wanted. Obviously we could speed it up if we wanted to. The easiest way to do that is to decrease the delay. Why does it appear to be 2 lines? It's because the underlying code that's actually doing the rotation, once I set the coordinates, it draws the new line and then erases the old line. And so we see 2 lines all the time, which is a little disconcerting. We could drop this to 5 degrees and make this 25 milliseconds. So now the fact that you're seeing 2 lines doesn't look quite as bad. Cut that to 2 and cut that to 10. I think that's the same proportions. There we go. So a little smoother. You can still see the 2 lines kind of, but it's not as bad. Now if you want it to move, now you have to change self.x. Self.x plus equals 0.1 and self.y plus equals 0.05, and now it'll rotate and move. Yeah, I made it move slowly enough, it's not very obvious, but you can see it's further to the right than where it used to be, and eventually it will eventually it'll hit the ground or the right hand side of the window. Not sure which it's going to get to first. So you can translate and rotate at the same time, and it's pretty easy. Now it's hitting the ground. Okay. So that's rotating a line. That's fairly simple. Of course we can have multiple lines. We always have to try that, right? So we're going to put let's see, delta angle and Vx and Vy. And then instead of doing a loop, I'll just do a separate one here. We'll make this 400, 100, 110. Delta angle, so we're going to make this one -2, -0.2, 0.1. And since I've added parameters there, I have to come down here and add them. And this was delta angle Vx Vy. Self.delta angle equals delta angle. Self.Vx equals Vx. Self.Vy equals Vy. And so now plus equals self.delta angle plus equals self.Vx self.Vy. Wow, kind of interesting. They're spinning at different rates, moving different directions, and one's longer than the other one. Wow, how could we possibly have more fun than that? But let's put our lines away for a moment. Well, I guess we could put the flowers back in for... No. And let's do a rotating polygon. And we'll give it a center X and a center Y. and we're just going to do a delta angle this time. It's easy enough to do a translation as well, as you've seen. This is just going to do a delta angle. So class rotating polygon. Don't need the parens there because I'm not deriving from another class. Def init self x, y, delta angle. So you recognize this pattern right now. Self dot y. Oops. You would recognize it if I completed it. Equals y. Self dot delta angle equals delta angle. Self dot polygon equals canvas dot create, not draw. So what are we going to try and do? Let's try and do a hexagon, six-sided shape, right? So we're going to say angle a side, because we're going to draw the six sides in range 6 angle equals side times 360 over 6. So that gets so for each side we're going to step 60 degrees, or a sixth of a total circle, and we need to I don't know why that key does a different thing than I expect. I really have to look up and see what that key does. So this is degrees to radians. Actually, we're going to set an angle step here. So angle step equals degrees to radians 360 over 6. Now, why don't I just put 60 in there? I could, and really this isn't that obvious. In fact, I should have n sides equals 6, and then if I said divided by n sides, that would make it a little clearer, right? So 360 is recognizable as the degrees in a circle, maybe, but 6 is better replaced with n sides. So angle equals angle step, and I've got two sets of angles going on right now. This is the amount it's going to rotate by, the delta angle. This is for drawing my polygon, okay? Equals angle step times side. And so now we need to get the coordinates. Oh. I need one more parameter here, sorry. The radius. Usually we use radius to mean the radius of a circle, which is what it should be, but this is going to be the distance from the center of the polygon to each vertex. All right. So let's add a radius here. Where did that go? We'll make the radius 40 just to start off with. I think I had those backwards. Okay, yeah, radius delta angle. All right. so now we need this is x0 equals x. So my first vertex is going to be straight above the center of the polygon, okay? y0 equals y minus radius. And I haven't stored self.radius, and I don't really need to. Yeah, I do. Sorry. Self.radius equals radius. Okay. Let's see. Okay. I should have set these before the loop. Not that it makes much difference, but they're not dependent on the loop, so they should have gone up there. Okay, x0 equals x, y0 equals y minus radius. Yep, okay. So x1 equals, now it's radius times math.cos angle. So not too surprisingly, y1 equals radius times math.sine angle. Oh, that's why I have to create the polygon all at once. So let's see. So vertices equals x0, y0. That's okay. That's what I was missing here. So I can't do create polygon yet. I need to say vertices dot append x1 vertices dot append y1. Okay, that's what I was looking for. So I didn't really need to have xo and yo. I could have just put them into this list. Can I create polygon from a list? tk enter create polygon list. Yeah. That's not very nice. Oh, I guess, okay, I'm sorry. So what I need to do is, oh, this stinks. I'd like to create it from the list. Let's see if I can create the polygon with no parameters. And then stop that. Canvas dot chords self dot polygon vertices. Let's see if that works. Don't know if it will, but it's worth trying, right? Nope, didn't like that. Tuple index out of range. 170. Okay, so let's do 12. No, it's not 12. It should only be 7. Oh, it's 12 because there's 2 for each point. 7, 8, 9, 10. So I'm just giving it random numbers for the vertices. And then I can set the coordinates this way, I hope. Let's see what happens. Well, not quite what I was hoping for, but at least it's something. I think we're going to have to go into the debugger now to see what went wrong. Rotating polygon. Yeah, I don't want that breakpoint. Do I? Yeah, actually, that is where I want to break. Okay. Restart. Everything we got to there. Okay, so vertices 380, 40, 0. Oh, that's not at all right. Huh. Okay, what's angle step? 1.04 radians. Yeah, that's right. There's 2 pi radians in a circle, so 6.29 roughly. So a sixth of that is just a little bit over 1. Coordinates. Let's see, vertices is what I want to look at. So 380. Oh, I know what I forgot. I forgot to add on. This is x plus, and this is y plus. I need to add on the center of the polygon. Okay, now we're a little closer. Why did that go like that? Huh. 1, 2, 3, 4, 5, 6. Okay, so it has the right number of vertices. Vertices is 0 to 13. Okay, so I'm closing it myself. Which I potentially shouldn't do, but let's add on 2 more there. Let's see what that does. Yeah, it looks pretty much the same, doesn't it? Okay. What happens if we get rid of those and try going 1 less than that? Well, that gets rid of the squiggle up there, but it sure doesn't. Oh, my first point shouldn't have been directly above. It should have been over here. Okay, so I really don't want XO, YO at all. I want an empty list, and I want to do all the sides. So instead of me calculating the first vertex, I should have let it calculate all of them. And let's see what happens now. There we go. That looks like a regular hexagon. Okay, so now we want to rotate this thing, right? So we do root dot after 100 rotating polygon dot rotate self, and you recognize that pattern too. So def rotate self. There we go. Now I'm going to do very much the same thing that I did before. So I need to chop some of this code out and put it into a common area. Let's see. So let's have did I do a self.angle? I didn't do a self.angle. And so this should really be, so we're going to find everywhere it says insides, and we're going to do self.insides. Okay. We're going to say self.angle equals 0. And then everywhere it says angle step, we're going to make it be self.angle step. And then we're going to say, we're going to put the polygon creation up here. And we're going to call self.rotate. And now def rotate self. Now we have the empty vertices. For side and insides, angle equals self.angle step, so it's self.angle plus self.angle step, and that will do the rotation. Oh, I need to remember to say self.angle plus equals self.delta angle, right? Let's see what that does. Oops, x is not defined. Well, okay, I can see that. Self.x and self.y. Is there anything else in there that I missed? I think that does it. No, that didn't. Name radius is not defined. Okay. Okay, those two there. Let's try that. Huh. It's going backwards. It's because I forgot to reverse the y. And let's make this faster. And let's make the delta angle. Where did the delta angle go? Let's make that much smaller. Let's see what that looks like. Still going backwards. Why is that going backwards? Huh. Well, anyway, so now you can see I have I've written a very general routine called rotating polygon, or general class. And if you passed in the parameters, so right now it's, so let's do insides here. We'll make that the first one. And then in self.insides equals and sides. And 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, that's right. I've still got the problem of how do I create the polygon. Let's try this. Let's see what happens if I just give it 1 point. And I need to go back up here and do n sides, right? We'll stick with 6 for just a moment. Okay, so having just 1 point worked. It still turned it into a hexagon when I set the parameters. So now, if I have pentagon, .380, 120, and we'll make its side 50, and we'll make him rotate just a little bit slower. Whoa! He's really buzzing. Why is he going so fast? And this one's going the right speed. Where did I add? So I need to make angle here. I need to leave one of them. So, okay. I'm mixing radians and degrees is the problem. Okay, self plus delta angle, self dot angle. So this is now degrees to radians. Like that. Okay, let's try that. There we go. And that's why it was going backwards, was because I was adding on that funny angle. But because it was so close to 1, we didn't notice it. So let's make this be 400 so they're not running on top of each other. Look at that. And so now they're rotating. And so if you wanted to do a more general purpose, so this one is limited to regular polygons because of the way I'm drawing the sides out. If you how could we make it a generalized polygon? Let's see. So for a generalized polygon, I see. Okay. So a generalized polygon would be somewhat harder in that I would have to deduce these angles instead of calculating them. Should I leave that as an exercise for the student? No, because it involves math, and I don't really want you guys to get killed with math. So let's make sure we know what routine to use here. Let's see, Python A10-2, math.A10-2. Okay, good. There's two kinds. There's A10 and there's A10-2, and that's how you can figure out a function from a set of points. And, well, I'm not going to explain all the math. You can look it up if you want to, or you can take it on faith, whichever makes you happier. And so let's do a generalized polygon. And it's going to take a rotation point. So I'm going to comment these out so they don't interfere. And so, stop that. Okay. So there's a point that it's going to rotate around, all right? And we'll make that 300, 150. And then it's going to take a list of vertices, all right? And so let's do so if I'm centered at 300, 150, I'm going to start off at 300, 140, so just a little bit above the middle, and I'm going to go straight up to 300, 100. I'm going to come back to 250, 120, and then I'm going to go, so that's 1, 2, 3, and then I'm going to come back to 300, 160, and then we're going to have 300, 120, 340, 150, and 320, 160. Don't know exactly what kind of shape that's going to give us, but we'll actually, let's do our delta angle right here. Now obviously I could do color and everything as well, but we're not going to right now. So once again, class generalized polygon. Definite self. I'm going to name these center X, center Y, delta angle, and then vertices. Okay, so now we've got self.center X equals center X, self.center Y equals center Y, self.vertices equals vertices, self.delta angle equals delta angle, and self.angle, as always, we'll start it at 0, right? And then we're going to say, oh, self.polygon equals canvas.create polygon. This all looks familiar so far, right? And we'll just make it 0, 0 because we don't really care what that is. And then we're going to call self.rotate. Why do I break self.rotate? It's so that I can have the dot after there to keep it moving. So this is rotate, if I can spell it right. Say def. Okay. For index in, let's check something first, okay? If lang vertices modulus 2 not equals 0, print need an even number of vertices, raise value error. I think that's a valid. It changed color. It must know what it is. So we want to make sure we have an even number of vertices, xy, 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 xy. Okay, so now down here we can say for index in range lang self.vertices over 2 and we forgot to, so self.angle plus equals self.delta angle. And they're all degrees so far. Okay, so angle equals, and this is where it gets interesting, no, oh, I don't need a self.angle. Interesting, because I'm calculating all the angles. Okay, so the angle is A10-2, remember we looked that up, and it's probably, what's xy? Oh, okay, what order are the parameters? It should be yx. That's really nice. They don't tell you. Oh, there we go. Yx. Yes, that's how it should be, even though that's backwards from normal. And so this is vertices sub index plus 1 minus self.center y vertices sub index minus self.center x. So now, since that's in radians, I'm going to make this radians right here. Degrees to radians, delta angle. And so now we can add on plus self.delta x, delta angle, sorry. And then we can say vertices, oh, I need a radius also. So we'll take this off for right now. Radius equals math.square root. Alright, so now I need a dx and a dy. Okay, dx equals that, dy equals this, so I'm going to need this measurement for the radius also. So I'm saving them in variables. A10 dy comma dx. Okay, math.square root dx times dx plus dy dy times dy. Okay, so that is the angle and the distance to the to the vertex. Now I have to rotate it. Angle plus equals self dot delta angle, and now I say x1 equals radius times math.cosine angle. Oh, so it's self.center x plus that. And now sine. This is 2 times index, because I want to step across every other vertex. And then we can do canvas dot chords self dot polygon vertices. And actually, oh yeah, all right. Root dot after. We're going to give ourselves a half second in between times. Generalized polygon dot rotate self. And you recognize that pattern too. But now we get to see if we recognize what happens. I can't say. Alright, so I'm going to say not equal like that. Delf is not defined. Interesting. See, and that's why I should. Well, self is hard to complete because it's so short. Let's see what happens now. Float object cannot be interpreted as an integer. Really? Where is that at? 193. Try that. Vertices is not defined. Ah. I forgot to set that. Okay, so this needs to be vertices, and I'll go back and correct vertices everywhere. 2 times index. Vertices 2 times index plus 1 equals that. And now every place I have vertices, I need self dot vertices. ATM2 is not defined. Of course not. Okay. Well, that wasn't exactly what I was hoping for. Oh boy. Keyboard interrupt. Okay, so something went badly wrong there. So let's start off with, let's see what I'm actually drawing, okay? And let's do word generalized. And let's make his delta angle be 0. So he's only going to draw once. It's kind of a bent arrow, but okay. So that's what it's going to look like. And we want that to rotate just a little bit. So let's come back into here, and this is generalized polygon. Okay, so we're going to stop right there and see what's happening. Okay, vertices is 14 long, so that should pass. Right? So F10. Okay. And center X and center. Well, that's getting communicated correctly. Self.polygon, self.rotate. So we need to step into that. And we can grab this, come to our debug console and make sure that that comes out as 7, okay. dx, oh, dx is 0, dy is -10. Now there's a problem, because A10(2) should give me an error if dx is equal to 0. It didn't raise an exception, but let's put that in there anyway. If dx not equal to 0, else 0 if dy this gets messy. Okay, so if it's pi over 2, if math dot pi over 2 if dy is less than 0, else 3 times math dot pi over 2. So those are the angles where dx can be 0. And again, you may just have to take that on faith for a moment. But that is always a problem with rotations, is with atan, is you can end up with a divide by 0. So let's see what that does, if anything. Why did that come out different? Well, probably because I was hitting a 0 before. So let's try this and see if it behaves any differently. No, that is still going into an infinite loop somewhere. And so let's follow this down here. Wait a minute, why am I setting the coordinates inside of the loop? And my root dot after as well. Let's see how much of a difference that makes. Probably not much, but it might because of the dot after. Nope. Well, at least it doesn't freeze anymore. But that sure doesn't look like it's rotating, does it? Looks like it's doing push-ups of some sort. Okay, so now don't want a breakpoint there, don't want a breakpoint there, we want a breakpoint right there. So restart, bing. Okay, vertices, it's 14 long, so that works. Oh, I was supposed to stop down and rotate. Okay. So self.vertices, that is 300. Self.vertices, that is 140. I think that's what we put in up here. Wherever it went. 300, 150. Oh, 300, 140 is right there. Yes. Okay. Now we can just look for a green line again. Okay. So dx is, I could look for it up here, 0, and dy is negative 10. That's correct. And angle is equal to 1.5. That's pi over 2. So that is what I expected. And the radius should be 10. Yep. And so angle now is, what is delta angle? Oh, 0. Huh. So I should have fixed that before I tried to do the rest of this. So now we need to restart. Okay. I got to put this in the right place, shouldn't I? That's where I want it to be. So run to the next breakpoint right there. Okay. So dx is 0, dy is negative 10, angle is pi over 2, radius is 10, yep. Angle is that, so it's greater than pi over 2. And then self.vertices. Oh, I lost my debug console. Oh, heck. Well, so it was I thought it was 300, 140. Wasn't it? 300, 140. And now it's become oh, that's 299. I thought it was 200. Okay. So x, y. Y shouldn't have moved that much. Self.center y is 150. Oh. should have been 140. Oh, minus. I always forget that y is upside down. Oops. Okay. So let's revert that. There's the minus. Let's try this. Well, that's closer to a rotation, but we're not there yet. What's our rotate step? Was it 5 degrees? 5 degrees, yeah. So we're not there yet. Let's restart this. And self.vertices. Let's see. Vertices 300, 140. So angle equals 1.57, 1.65. So this was 300, 140. It should be just a little bit less than 300 and a little more than 140. A little less than 300. And it stayed right at 140. I'm not sure I believe that, but I guess that's possible. Oh, okay, it was displaying wrong up there. 140.03. Should have been less than 140. Why is it more than 140? Where's my... math.sin angle. Yeah. Center y minus radius. Times that. Okay, so radius is 10. That's a little less than 1. So let's see what that is. Oh, no. Self.generalized 150. Yeah, I'm looking at this backwards because it's upside down. That's why it's okay. All right, so that seems like the right value there. So what's the next vertex? 300, 100. Okay. Angle is still pi over 2 because dx is still 0. Angle. So it's 300, 100. Now it's 295, 19. What was radius? 50. radius to the second one be 50? Sure is. So it is 50. Alright, shows what I know. And so dx is negative 50, dy is negative 30. Angle is 2.6. Yeah, that sounds about right. Radius equals 58. I can believe that. Angle plus equals... Wait, why is it negative 2.5? Oh, alright. Yeah, I can picture that. So the vertices were 250, 120, 52, 184. Seems right. It really looks like it's doing the right thing. Let's see, where's our picture? Oh, because this is the first time, so we haven't rotated yet. Clear that one for right now. Let's run to there. So what do the chords look like? Oh, I want to look at vertices. That all seems reasonable. So let's stop here, and now if I continue I should get a picture. The picture looks like that. Oops, that's right, I need to clear that. Let it run, and that didn't regenerate because of the breakpoint. Curses. So what can we do? We can, so it's every half second. Tell you what, let's do a simpler shape so we can kind of see what it's doing, alright? So I tried to do something complicated here, and that didn't work. So let's do 350, 150. So that's 50 to the right and level. 300, 100. So that's 0 to the right and 50 up. 250, 150, and 1, 2, 3, and then one more point, which gets us back to 300, 200. So let's set our rotation to 0. And then get rid of this. So it should draw a square. A rotated square, but yes, a square. Alright. So now let's set the rotation to 5. Let's see what it does. Well, that looks like that rotated approximately correctly. Alright, let's take this out. Let's see what that does. Oops, I forgot to kill it off. It's just bouncing back and forth. Interesting. Let's try something here. Let's do a radians 2 degrees. Return number times 180 divided by math.pi. And then we can come down here and we can say if, don't need a paren, this is Python, index equals 0, print angle radians 2 degrees angle. Negative 4.9 and then 0. Okay. Why is that bouncing back and forth? It's because of this. Need to no, that's not right, is it? Yeah. Oh, no, not that. dy should be the negative of all of that. Let's try that. Ho 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 ho. Okay, so it had to do with misunderstanding the coordinate system again. So now we can get rid of this. And now we can we'll make that 50, and now it won't be a regular square anymore. What we want to see is it centered on that point? I'm pretty close to the center there. Yeah, that looks like the center. So let's go down here and change this to 50. Whoops. So when it hit, this is this case right here. It's this one right here. There we go. So now he doesn't get inverted. Very good. So there is the generalized polygon after all the errors I made. Obviously we can still do, we can do different things here. Of course right now all I'm doing is messing around with. And that's the other thing, is if I move the point, so that point is now outside of the polygon. So now it's rotating around this point out here. Okay, so the point doesn't have to be in the center of the polygon. It can be anywhere you want it to be. So once again, is there more I could do with this? Sure there is. We could uncomment everything. And we've got all sorts of stuff going on here. That's a very busy picture. And there, one of the lines went off screen almost. The other one's heading off screen. Nobody else has a constant velocity, so they'll all stay on screen. Isn't that fun? Just tell me yes. If you stuck it out this long, hey, congratulations. Thanks for